Morning, guys. Sorry I am not here today. That was a very weird echo. Hopefully, that is only briefly in that moment. It seems that we are still recording a voice. Good morning. Sorry I couldn't be here. I'm out here hanging out with Dr. Teston and Coach Lowry down here at this terrible Golden Blue school, um, exploring their baseball facility so we can get some ideas that we can do for old Winchester Park. We're going to go through these four lines. That way, you guys have the rules that you can add to your foldable. Okay, we're going to talk about a couple of lines. So, we're going to go through y equals x, y equals negative x, and then we're going to talk about reflecting over a horizontal y equals line and also reflecting over a vertical x equals line. So you guys can follow along on your notes. Y'all can pause or whatever you need to do, but we're going to work through these problems. So when we reflect across the line, y equals x. So I want you to remember way back to your old pre-algebra days when you had to graph these awesome linear equations. Y equals x is just a 1-to-1 ratio. So if x is 1, well then lo and behold, y is going to be 1. And if x is 2, y is going to be 2. It's beautiful. Okay, so if we graph this line, it kind of goes right through the middle. Sorry if my line is terrible, but there we go. That'll be better. Okay, so we're going to take our three values, just like yesterday's values, and we're going to reflect across, now, not the x or y axis, but this y equals x line. So if you remember, 3, 2 was here. Boom, there's 3, 2. Probably should turn off the straight line tool. Okay, there's 3, 2. We're going to do colors again, -1, 3. It's beautiful because we still have the same numbers from yesterday, so you guys can kind of still follow along. Okay, and our last one was obviously 1, 0. So remember, when we reflect across the line, our reflector, our line of reflection is going to create a perpendicular bisector. So it's going to perpendicularly bisect, and it's going to be right here. So we're getting 90. So our new location is going to be right there. Okay. So if we looked at our original line and what our new line is, this one's pretty easy. It's kind of short, not as difficult to look across the pond there. Our new ordered pair becomes 2, 3. Okay. And we do the same thing for the red. All right, let's go with the green because it's not quite as far. So again, we want a perpendicular bisector. So equidistant from our line of reflection on each side. And our new coordinate is going to be 0. That wasn't a very good 0. 0, 1. Hey, and again, our red line's pretty far. It's okay. We're pretty smart folks. So what, about right? My guess is about right there. Well, if I can get my line tool to cooperate. Probably about right there. And it's going to end up right about here, which would be, again, it got to be equidistant. It's got to cross at 90 degrees. That's why it's perpendicular. So I'm going to say 3, -1. Now, if we look at our three values, what is really happening? Okay, so I went from a pre-image of 3, 2 to an image of 2, 3. Then I went from a pre-image of -1, 3 to an image of 3, -1. So our rule is awesome. We're just going to flip x and flip y. So where x was 3 in our pre-image, now y is 3 in our image. Where x was 2 in our pre-image, y is now, or where y was 2 in our pre-image, x is now 2 in our image. That's reflecting across the line y equals x. Okay, let's look at reflecting across the line y equals -x. So positive slope goes up, negative slope goes down. All right, there it is. That's the line we're going to reflect now. So, handy dandy points, 3, 2, negative 1, 3, and 1, 0. I did not do different colors. My bad, guys. I'll fix that. Red dot, stay consistent. Green dot, thanks for coming. Okay. So now we have these lines. Again, we're going to flip here. So it's going to go across. New line, perpendicular to bisect. Thanks for coming, green. So I'm at what? 0, negative 1 now. All right. Let's look at the blue line. Well, let's go with red. Blues are a difficult one in this one. So we're going to look at red. So red goes from negative 1, 3 over here to negative 3, 1. Can we see the pattern that's happening this time? Starting to look at it, trying to figure out what's going on. That's a terrible one, isn't it? And then our blue line, let's see what blue does. He's at 3, 2. I bet he's going to be at negative 2, 3. Negative 2, negative 3. If I can ever get my line all the way over there. Okay, remember perpendicular bisector, makes a right angle. Thanks for playing. So that guy's going to be at negative 2, negative 3. So what does it look like our rule is? All right, so I went from 3, 2 to negative 2, negative 3. It's very common to the one above it. Okay, but this time I've got to negate y and negate x. Okay, so there's our rules. There's 2 more rules for your reflection sheet. That should fill out box number 3 and 4. Okay, that should fill out the top part of our foldable, and all we got left to talk about on our foldable is rotations, which we'll do next week. But now let's look at when we're flipping a horizontal or vertical line. Okay, we want to reflect across the line y equals a number. All right, so let's say number y equals, where do you want to go? Number, let's stay away from anything that's not involved. Let's say y equals negative 1. So we're going to reflect the line y equals negative 1. Sorry that took me so long to think. Sometimes the old noggin doesn't do what it should. Okay, so we're going to draw our y equals negative 1 line. Boop, there it is. Okay, so you guys did a little bit of this on your homework last night, just trying to ease your feet in, testing the waters of the old pool before you just go jumping head first. Okay, we're going to draw our lines on there, 3, 2. Our trusty 3 points that we've been using the last 2 days. Negative 1, 3. And then Mr. 1, 0. Okay? So, I want to take my red, blue, and green dot, and I want to flip them over my y equals line. These are very close to doing exactly like our vertical and horizontal lines we learned yesterday. Okay? What I need to know is how far is it to make them a perpendicular bisector. Okay, remember I've got to bisect the line. So how far is it from my pre-image, we'll call that guy A, to my line of reflection, my LOR? Okay, so from positive 2, did I mess that up? No, we're good. Positive 2 to negative 1, that's 3 units. So I need to make sure that if this length of my segment is 3 units, then the bottom length of my segment needs to be 3 units. So from my line of reflection, so from negative 1, 1, 2, 3, old Tootsie Pop commercial. None of you guys know what that is. I'm sorry. Okay, so there's our line of reflection. I should be 3 units up here, 3 units down here. So our new line is 2 or 3, negative 4. Okay. We're going to do the same thing for old green boy there. It's going to go nice and neat in order. So he's easy. He's only got to go down one to the bottom, one to the left. There he is. So we got -2. Don't do that. So I've got 1, -2. All right, and then our last guy, Mr. Red over there, how far is he away from the line of reflection? That was a terrible line. He is 4 units, so I've got to make sure I go 4 units down. Puts me right here because these two lines have to be bisected. So now I'm at -1, -5. Okay, these rules aren't really as clean. Okay, they're not as clean, which stinks. All right, it happens. I'm sorry. But we do got some little common points. X not going to change. Okay, we're jumping a horizontal line. X is going to stay the same, just like jumping that x-axis yesterday. All right, so what I would say, if you want to have a rule, if you don't want to count boxes like we did, I would say it's y plus or minus the distance to the line of reflection times 2. So if the line of reflection was 3, multiply it by 2. Okay? I'm going down, so it's negative. So 3 times 2 is 6. 2 minus 6 is -4. It's magic. It'll work. It's not quite neat and bow-tied and all cleaned up and pretty, but it works. Right? And our last one, we're going to reflect across a vertical line. So we want to reflect a x equals line this time. Okay, we're going to go, make sure we don't cross anybody over. So let's go x equals 2. So we're going to jump the line, x equals 2. Because we're cool like that. Okay, so I've got my vertical line at x equals 2, which is an undefined slope. Good job. See, we just mix everything in there, kind of recuperating, reliving our glory days in Algebra 1. And let's see. Let's get Mr. 3-2 on there. Hey, buddy, how are you? Haven't seen you in a long time. Mr. -1-3. Thanks for coming. Good to see you. And then finally, 1-0. Okay. So we got to jump lines again. I'm going to stick with green because my pen's still green. Sorry about that. So 1 unit here, so I'm going to go 1 more unit to the right. So I go from 1-0 to 3-0. Okay. Let's go to red. Red is 3 units away from the line of reflection. So he's going to go 3 units away from the line of reflection to find his image. So his new location is 5-3. And then, of course, blue. You're my boy, blue. But you are only going to go 1 unit. You're making our lives a little easier. At 1-2. Okay, let's look at the rule. One last check. Okay, let's do red because he's so far. We went 1, 2, 3 units on red. Sorry about that. So he went 3. So again, y is not changing, just like on the x-axis. I'm going to go x plus or minus, just like up here, the distance to our line of reflection. I'm going to abbreviate this time though. Distance to our line of reflection times 2. So 3 times 2 is 6. If we take 6, add it to our original x value of, oh, not even close with that arrow, was I? There he is, -1. -1 plus 6 gives us 5. All right, you guys' homework is a PDF. Get it done, and I'll be here later this afternoon. If you have any questions, come by and see me.